Hello and welcome to another quick maths tutorial. So today we're going to be looking at the product rule, as I said before. So we've looked at the power rule and the chain rule before for finding derivatives, and there's another one. There's more, don't worry. This one is the product rule. So as you can see, we use different rules depending on what sort of function we have, or equation, if you like to think of it like that. And obviously, so if it's in a certain form, you can't use the power rule, let's say, or the chain rule. Maybe you can if you rearranged it, but if it's not very nice to rearrange, then there's a rule which can help you find the derivative by keeping it in the form you already have it. So here we have f of x, so a function of x is x squared times 2x. Now you could simplify that to 2x cubed as cubic, and we could then do the power rule. If you remember how to do it quickly, we take 1 from the power, so the cube becomes squared with the x squared. We'd move the original power down as it's times by the coefficient, which is already 2. So the 3 would times by 2 and we get 6x squared. So quickly I can already see this is 6x squared. But let's say it was something hard. I'm doing this because it's simple, but if it was something hard, we would need to use the product rule. And if we were to solve with the product rule, we'd have to use this. Doesn't look very nice, I know, but the derivative of f of x. Now this works, and I just want to point this out, when f of x is equal to some function g of x, that could be any function, times of some function h of x. So these two different functions multiplied together, that's what the dot means, multiplied. So that f of x is the product of two functions, so we have to use the product rule. And it looks quite horrible, but I'm going to explain it to simplify it a bit. All you have to do is find the derivative of one of these functions, doesn't matter which, multiply that by the other function, just as it is, and then we add the derivative of that other function, so h of x, times the first function, just as it is. So really, you could swap these two around. It doesn't matter which one's g of x, which one's h of x. It doesn't matter about the order, so you won't get confused. You just do the derivative of one times the other plus the derivative of the other times the original one, and that gives you the overall derivative of the overall function. So back to our original function. If I just draw an arrow down, what I'm going to do is I'm going to say that g of x is equal to x squared, and h of x is equal to 2x. So now knowing this, what we're going to do is we're going to put this into our product rule. So we do derivative of g of x, which I'm just going to write as 2x, times h of x, which is 2x. I'm going to do a plus here, and the derivative of h of x, which is 2 of x, is just 2 using the power rule. Sorry, and we're going to times that by g of x, which is x squared. Let's simplify this. 2x squared times 2x squared is 4x squared, plus 2 times x squared is just 2x squared. And there we get a overall 6x squared as our derivative. As I said before, if we just used the power rule in itself, but there you go. If it was something harder, we would have had to have used the product rule, but just showing you that it works when a function is in this form. So I hope that video helped. I hope to see you in the next video on derivatives.